content and steps of CNC machine tool programming. Since CNC machine tools automatically process parts according to the pre-prepared programs, the quality of program preparation will directly affect the correct use of CNC machine tools and the effectiveness of CNC machining characteristics. Therefore, in addition to being familiar with CNC machine tools, fixtures, and CNC systems, programmers must also be familiar with the math, content, steps, and programming standards, and continuously accumulate programming experience to improve programming quality and efficiency. The main components of CNC machine tool program preparation include analyzing part joins, process planning, numerical processing, writing the program shape, input the program into the CNC system, and program verification. Therefore, the CNC programming process refers to the entire process from analyzing part joins to program verification. Analyzing part joins mainly involves evaluating the material, shape, dimensional accuracy, and the shape and heat treatment to determine the feasibility of machining the workpiece. Formulating a CNC machining process involves determining the machining plane, selecting the appropriate CNC machine tool, choosing and designing tools and fixtures, determining the optimal tool path, and selecting reasonable cutting parameters. In addition, it is necessary to fully utilize all CNC machine tool command functions, correctly select the tool setting points, minimize the machining path, reduce idle travel and tool changes, and make numerical calculation convenient. After determining the process plane, the next step is to calculate the tool center path based on the part's geometric dimensions and the machining route to obtain the tool position data. Most CNC systems have linear and calcular interpolation functions. For machining relatively simple planar parts, composed of arcs and lines, it is only necessary to calculate the coordinates of the intersection or tangent points of adjacent geometric elements on the part contour to obtain the start, end, and arc center coordinates. For more complex parts, or when the part geometric shape is inconsistent with the interpolation functions, more complex numerical calculations are required. For example, non-circular curves, such as involute curves or Archimedean spirals, need to be approximate with linear or calcular segments, and under condition of meeting accuracy, calculate the coordinates of each curve node. For the programming of tabulated curves and special surfaces, the mathematical processing is more complex and generally requires computer-aided calculation. Otherwise, it is difficult to complete. After completing the process planning and numerical calculations, the part machining program can be written. Programmers write machining program segment by segment according to the instructions and program segment format of the CNC system used. Programmers must be familiar with the CNC machine tool performance, program instructions, and the machining process to write a reasonable program. After the program is written, it is best to verify the program using CNC machining simulation software. Then, input the program into the CNC system directly through the machine tool panel or via a disk drive or USB interface. Generally speaking, before formal machining, the program should be verified. For planar parts, a pen can be used instead of a tool, and coordinate paper can be used to perform dry runs and drawing. The program can also be verified by checking the correctness of the machine's actions and movement path. On CNC machines with graphic simulation functions, the program can be checked by displaying the tool path or simulating the cutting process. The program should be checked for complex parts, materials like aluminum, plastic, or wax should be used for trial cutting. By checking the test piece, it is possible to confirm whether the program is correct and whether the machining accuracy meets the requirements. This concludes the introduction of the content and steps of CNC machine tool programming.